All right, I'm going to make some erasures here. This is the last problem that we're going to do. I shouldn't say the last one. The optional ones you can do if you want, but I'm looking at 16, and I'm looking at it. And granted, what happens is people get tired and they say, I don't know what to do. I'm just going to try. I can't say enough times, look for that GCF. Is there a GCF between 18, 24, and 64? I'm going to say the number 2. Now, I'm also seeing a y as common, and we left off with 9y squared plus 12y, and then you're going to get minus 32. Now, granted, these numbers are not pleasant, but you could try. I mean, I would definitely go with trying on it. I wouldn't go with the AC rule. I will do AC on it, though. But AC to me is problematic. So 2y. If I were trying, though, I would try to stick with really small numbers. So, for example, 9y squared, I would say maybe 3y and 3y. I'm not saying it's going to work, but the only other choice is 9y and 1y. I'm using smaller numbers to make it easier for me. Now, if I'm looking at 32, you could say 32 and 1. I just don't see it as being a reasonable choice. You could do 2 and 16. 16 is kind of a large number, by the way. But I'm not saying it's wrong or right. But I'm going to go with 8 and 4. Now, someone says, where do you put it? Anywhere you want to put it. I'm not going to say it's working, but you need to get busy trying something. Now, looking at this, I don't know, 3y times 3y is definitely 9y squared. And 8 times 4 is definitely 32. But I need the product to be negative and the sum to be positive. So I'm looking at that, and I'm going to say it looks likely that this might work. How do I do that? Multiply it out. 3y times 3y is definitely 9y squared. 8 times minus 4 is definitely minus 32. Let's look at the internal sum, though. You get minus 12 plus 24, which of course is 12. This is a correct factorization. All right, let's take a look at the key. 2y, 3y plus 8, 3y minus 4. Remember, the order of the factors is incidental. All right, let's use the AC rule, though. And to do that, I'm using the AC rule on this thing over here. I do see it as being problematic, though. A, which is 9, it's quadratic in y, by the way, and minus 32. All right, right now it's problematic. I have to do multiplication. So 9 times minus 32 is minus 270, and then an 18, and that's going to be 288. It's problematic right there, all right? So again, 9 times 30 is 270. 9 times 2 is 18. I have to find two numbers that when multiplied together would give you minus 288, but those same two numbers, when added together, is going to give you 12. All right, it's problematic. And so why is it problematic? I got to look at the 288. And let's take a look at it. And so it's really difficult to do that. It is. This is what's problematic about it. So 2 times what? Let's look 144, right? All right, let's do that again. That's 4. And let me get there. 4 times what? I took a 2, right? That's going to be 72. And you keep playing around. You're going to take a 2 from the 72, and what do you get? You get 8 and 36. This is why this is so problematic, by the way. All right? Now, someone says, am I even getting close to this at this point? Well, let me take another 2, and what do you get? You get 16, and you get 18. And I'm going to say to myself, for the most part, this almost looks like a dead end to me. So I'm going to try 3. All right? I'm going to start with 3 instead. So let me just do a 3 now. All right? Now, someone says, how do you know 3 goes into 288? Add the numbers together. 2 plus 8, that's 10. 10 plus 8 is 18. Let me just write this down for you. 3 into 288. So let me take a look. I'm going to say, let's see 8. That would give you, what, 24, right? And then you get 48. I'm sorry. You know what I did? I'm daydreaming. Let me start that again. 3 into 288. 9. 27. 18. And what do you get there? Well, 3 times 6. So I'm going to say 3 and a 96. All right? And then, you say, what are you going to do now? I don't know, maybe I'll take another 3 from the 96, and you get 9. And this, again, this is why this is so problematic. Let me cross these out, though. I'm going to cross this one out, too, after I get done with it. Well, 3 from 96 would give you 32. Now, you may even forget why you're doing this. And the reason you're doing this, you're trying to get a product to be 288, but you want them to differ by 12. And this is certainly not going to work at this point. So let me keep moving. And I don't know, maybe take a 2 from the 32. And what do you get? 18 and 16. That's not going to work. All right. So, let's take a look. And I'm going to, maybe play around a little bit more. That's why it's so problematic. And let's take a look. And 18 and 16, let's kind of break it up. I'm going to say 4 times 4 here. And I'm going to say 2 times a 9 over here. Now I'm going to say 3 times 6. Oh, it's 24 and 12. Look at that. All right, 24 and 12. Now, how am I doing that? 4 and a 3. That's 24. And, 4 times 3 is 12. And the 6 times 4 is 24. Let's go back over here. And you might say, didn't you just do that with trial and error? I did, but I was a lot faster at it. So what do you say? I'm going to say 24 and 12 minus 12, 24 minus 12. Let me get my eraser out. I'll add scratch work on the side of using an AC rule. And I'm going to do it. And what I'm going to do over here, let's write this down. And I'm going to write 9y squared. I'm going to write down, 12y. Let's see, I'm sorry, not 12y, sorry about that. Minus 12y, 24y. I'm breaking the middle term into 2 parts, by the way, and then minus 32. Factor by grouping, all right? What do you do the first 2 terms? 3y, we left off with 3y minus 4. Next 2 terms, what comes out? 8. What do you get? 3y minus 4. Does that factor? Yeah, 3y minus 4 and 3y plus 8. What do you get? 3y plus 8, 3y minus 4. Again, your decision on how you're going to factor these guys over here, whether it's through trial and error or using the AC rule, or you're just really good at looking at things and knowing what the answers are, whatever works. Practice is going to make you really good at this, all right? It really does make you good at it. Thank you.